Okay, so we have a couple concepts. It's really just one, but diminishing marginal product. It's basically the same as law of diminishing marginal returns. It might go by different names, but all the same concept. To kind of illustrate this, it's better to just kind of read ahead here. So diminishing marginal product. The marginal product of an input can depend both on how much of this input is used and on the amount of other inputs used. It is then natural to assume that if we hold all other inputs fixed and continue to increase the amount of a particular input, then its marginal product should eventually start to go down. For example, think about a farm with a fixed amount of land and machinery. If we keep adding workers to this farm, eventually the new workers will not have much to do and will not be able to increase the production much. Similarly, if we fix the number of workers and the amount of land and keep using more tractors, we will eventually start to run out of drivers and land to use with these tractors. The basic idea that at some point the marginal product of an input must start to go down is also known as law of diminishing marginal returns. So that's basically a law of diminishing marginal returns. They talk about figure 3.2b. And then we have this little L hat, but let's just kind of take a look at, yeah, that's 3.3. I guess they went there 3 point, apologies. Okay, so we had said it in the previous video, but the 3.2b, yes, 3.2b, not a very big concept on the right, is going to demonstrate law of diminishing marginal returns, but that just means the more labor, there's more than one graph. This is, of course, marginal product with respect to labor. You can do the same thing with capital, and it's the same graph. But the more you increase labor, as we see, is labor goes to the right. The Y value, the MPL, yeah, the change in labor with respect to one increase, that MPL will always be ambiguous, very easy, the marginal of anything. But it's actually a very easy concept. We forget instantaneously, but it's easy. It's not like Q increases 1 unit. It's technically the amount increase or decrease in Q when L increases by 1. So this doesn't show the change. This shows, well, it does show the change. This doesn't show the amount of Q. It shows the rate of change. So the rate of change with respect to L is decreasing as L increases. They call that the fact that the slope is getting it is a negative slope, but if you take the absolute value, the slope is getting smaller and smaller as we go to the right. So it took me all of that to say that, but that one graph demonstrates the law of diminishing marginal returns. So we can kind of read through this if we want. They are going to have more graphs coming up. We just showed them. The L hat might be kind of a sweet spot. If we go past L hat, I think it's perfectly fine. We just, if we increase money, we increase labor and capital. As we'll see in the next graph, we just don't get as much kind of bang for our buck, as we might say. Yeah. So we see a quantity. It's not a derivative. It's quantity as a function of labor. Yeah, the quantity increasing. We can kind of read through the previous if we want to. And then they take the derivative, the marginal product of labor, the derivative of Q with respect to L. And we just see that the rate of change goes down after L. So do remember, it's not a big deal, but our money is increasing. It is increasing after L hat, just not as much. So if we add more labor, the production, the amount of Q that comes out, the quantity is still increasing, but the rate at which quantity increases with the increase in labor, the rate of change is decreasing. And please always do remember, it takes me a minute to get my marker because people know, but just remember the obvious, yes, that the slope here, yeah, the slope here is the Y value here. Yeah, when it comes to the second graph, we're not looking at the slope. When it comes to the derivative, we are looking at the Y value. What do we see here? That all Y values are positive. This Y value over here is way low. Yeah, but they still are above 0, which means if you increase labor, we still have a positive increase in Q. It's just, the increase in Q per L is way less than up here. That's the sweet spot there. But please always remember that the derivative, the slope here, the derivative is the slope. So the slope there is the Y value for the derivative. Just remember the obvious. That's always from calculus. Okay, so the law of diminishing marginal returns is pretty obvious here. Okay, so if we kind of have this going on, we can move on to the isoquants. Yes, so we do want to read a lot about isoquants. In our production technology, Q equals F of LK. The output is a function of two variables, hence we have a 3D graph. As we argued in the previous chapter, it is useful to use level curves to translate this 3D graph into 2D graph that is easier to work with. So we've had a lot of videos up to this point. It's taken a lot of videos, but chapter 2 is a math review. Most of it was just geared towards the Cobb-Douglas and this one thing. This exact thing, the isoquants are the contour lines that we discussed before, and the contour lines are the isoquants. And then in chapter 4, they're going to be iso something else, but this is isoquants, yeah. So the isoquants are specifically the contour lines. For example, figure 3.4 depicts some of the level curves of the Cobb-Douglas production function. We have a function there. In economics, we have a special name for the level curves of production functions. We call it an isoquant. Each isoquant connects all the input combinations L and K that produce the same. So we see it there. If we remember the basic 3D graph from before, those are the isoquants and they are the contour lines. So those contour lines are the isoquants. They get really in detail, which we're going to do in the next video, kind of describe the slope and all of that. That's what's coming up for the isoquant. We have to do this in the next video. They go in great detail over this one thing, but one isoquant is one Q. So that's the whole point. If we make one simple point about the isoquant, this is all the isoquant is, all it will ever be. But one contour line or one isoquant, yeah. So remember, Q is coming straight up out of the page. The F of KL, which is Q, it's a three-dimensional graph coming straight up out of the page, is what it is. Yes, and one of these is one Q. So this isoquant, this contour line, this isoquant, is going to be Q equals 80. So what does it represent? It represents every combination of LK such that Q equals 80. And that's the only point. That is the only point of the isoquant, is that one contour line, the isoquant, will show us all values of K and L such that they produce the same Q. Yeah. If we're on a different isoquant, that's Q equals 60. The quantity produced is now 60. If we have 6, then we have, something like less than 3, between 2 and 3 over there. So all of that is kind of the point. Okay, so with these basic descriptions, it always takes kind of a lot to explain. We're going to go into that, yes. Okay, so we're going to jump into all of this in the next video. So we'll kind of read through. This is all for the next video here. Let's just kind of jump into the next video.